Hello everyone, this is a Team Yellow's BS339 Supply Chain Management class presentation.
The manager of Quality Parts Company plans on making 4 changes to its organization. Of the 4 changes, only one has the potential of being consistent with Lean philosophy. That is, investing in an automated ordering system. If implemented correctly, there will be a reduction in human error compared to a manual ordering system. It could also improve efficiency, leading to orders being fulfilled faster. However, if the system is too complicated to understand, it can lead to more issues when it's not functioning right. Also, this could lead to higher levels of inventory rather than just focusing on demand. Another change the manager has is to add a rework line. This would be against Lean principles since it's spending money to find solutions after producing a product rather than while making it. The manager also plans to add high-rise shelving. Although this will be helpful to stay organized, it can easily lead to keeping more inventory than needed on hand, and just simply adding an additional step to the operation that wastes time rather than improves the process. The last change the manager plans to do is to add inspectors. Lean philosophy focuses on eliminating waste and defects. Adding inspectors will help find them, however, it won't help to reduce them. This may lead to different departments not checking on the quality of their work in the moment since they expect the inspectors to find the defects after.
That can be used for improving such areas as scheduling layout, Kanban task groupings, inventory, and supply chain. So for scheduling, using Kanban to visualize the progress of a task will assist in workflow and letting everyone know how work is progressing and the time needed to complete it. By utilizing this data, the company should be able to operate efficiently out of a schedule that's focused on meeting demand. Knowing the range of demand from the customer's past orders will allow Quality Parts Company to come up with a schedule that uses every department effectively. Another effective method is changing the layout so that the machine 4 is closer to the assembly line. However, assembly step 1 has an operation time of 50 minutes. This causes their work in progress to evaluate throughout the day. By moving it closer, there is less time wasted on transportation. This will lead to assembly step 1 to start closer to when machine 4 starts on the next one, ultimately helping to reduce the amount of work in progress throughout the day. Another one is the Kanban. Using a two-bin Kanban system will help know how much inventory is on hand. Another recommendation is task grouping. To run more efficiently, the machine department and the assembly department should be grouped together. Another recommendation is inventory. To help achieve a high volume of production, Quality Parts Company should implement JIT. Focusing on having the inventory needed to meet demand will be key in reducing the amount of time and resources needed for production. And the last but not least is supply chain. To help improve supply chain, the removal of operation number 5 will be removed. They will also be taught on preventative maintenance measures to help ensure that machinery is working efficiently. If downtime does happen, they will at least have some knowledge of their equipment, which will help them to get the machines up and running as fast as possible. This will ultimately help to improve production and finish at a quicker rate.
Question 3. Sketch the operation of a pull system for the Quality Parts Company's current system. A pull system in lean manufacturing ensures that production is driven by actual customer demand rather than forecasts. In that context of Quality Parts Company, this means that production activities only begin when there is a specific order or signal from the customer, indicating a need for more gizmos. And how a pull system works, or how a pull system would operate, is the process starts with the customer sending a signal such as a Kanban card or electrical order when their inventory of gizmos drop below a certain threshold. This signal is sent upstream to the final assembly station at Quality Parts Company, which then pulls the required number of gizmos from the previous workstation. Each workstation in turn only produces or moves parts when it receives a pull signal from the downstream process, ensuring that no station produces more than is needed at any time. The flow continues upstream through each process step, such as painting, assembling, oven, etc., with each step only producing what is needed by the next step triggered by actual consumption. The use of visual management tools like a Kanban board helps track work in progress and signals when to replenish parts or start new production. This system minimizes overproduction and excess inventory, aligns production with real demand, and highlights bottlenecks or inefficiencies for continuous improvement. Question 4. Outline the plan for introducing lean at Quality Parts Company. Implementing lean at Quality Parts Company requires a very structured approach that addresses certain inefficiencies and builds a culture of continuous improvement. First, we start with value stream mapping, which we begin by mapping the current state of all production and information flows to identify sources of waste, bottlenecks, and non-value adding activities. Then we would go to employee training. We would provide a comprehensive training for employees at all levels on lean principles, problem-solving techniques, and the use of lean tools. And then we'll go to keys and events, conduct focus keys and events to tackle specific issues such as quality problems, idle time on machines, and excessive inventory. And then we would implement pull systems. We would introduce Kanban systems to establish a pull system production, ensuring that each process step only produces what is needed by the next step based on the customer demand. Then we would go to a continuous improvement culture. We would foster a culture of continuous improvement by encouraging regular feedback, problem solving, and experimentation among employees. We would then do a sequence of lean principles implementation. We would start with value streaming and waste identification, move to employee training and Kaizen events, implement pull systems in Kanban, and continuously refine processes and sustain improvements. Then we go to use of external consultants versus internal training. A combination of both is often most effective, though internal lean consultants can provide expert guidance, a fresh perspective, and help jumpstart the lean transformation, especially in the early stages. Over time, invest in developing internal lean champions by sending employees for lean training who can lead continuous improvement efforts and sustain lean practices. Then we would go and focus on time frame. The initial lean rollout can be accomplished within 3 to 6 months. A full implement of pull systems and establishment of a continuous improvement culture may take 12 to 18 months depending on the company's size and complexity. Here we would show a summary of the lean implication plan, going step by step, the main points of action, the estimated time frame, and the responsibility. By following this plan, Quality Parts Company can systematically reduce waste, improve its efficiency, and build a sustainable lean culture that supports ongoing operational excellence.
Eliminating the queue of work dramatically quickens the time it takes a part to flow through the system. What are the advantages and disadvantages of removing queues? Eliminating the queue aligns with lean manufacturing principles by focusing on the reduction of waste, MUDA, shortening lead times and improving flow processes. For specificity, waste would be considered an implemented system that holds little value. The queue is traditionally deemed as essential to managers who often lead to disguises in inefficiencies and excess inventory. Reducing inventory queues minimizes inventory investments and shorten lead times, which in turn accelerate production. This leads to an increase in discrepancy visibility and exposure bottlenecks. Without queues' ability to hide these discrepancies, machine downtime, scrap, and delays become more easily identifiable, revealing root causes of any problems. Not all process improvements provide a high return of interest. Focusing on automations or altering workers' tasks lead to expensive implementation of new equipment or software. But shifting focus on reduction of wait times in between processes have a larger return of investment. This is due to optimization of time, the leading variable in efficiency. Despite the benefits, one of the biggest disadvantages of removing queues completely is the potential vulnerability of the system by removing redundancies or backup plans. Having a single point of failure poses major impacts for variables. In lean manufactured product, when minor disruptions occur like machine breakdowns, results can be catastrophic. Hence why decoupling operations from demands help mitigate risk while maintaining low inventory by introducing small strategic buffers. In the past, managers have used queues as a band-aid to resolve machine maintenance issues or poor quality processes. Lean shifts from focusing on revealing core issues rather than band-aiding problems. Removing queues can be effective, but only if the system is stable and well-maintained and supported. How do you think machine operators would react to change? How do you think machine operators would react to change? Initially, machine operators will most likely be resistant, mainly in the part of threat of potentially losing their jobs. There could potentially be anxiousness regarding job loss, reduced hours, and the transition will most likely result in stress for the remaining operators who will need to adapt to the new workload's expectations. It is probable that those individuals who struggle with change or are hesitant to adapt will experience frustration about their cut hours or even take it personally. However, the individuals that would prosper would be the ones who could see the opportunity for development and find the means to increase their job security by increasing their own skills and cross-training. Developing non-expendable skills, adapting to a multitude of roles, and increasing their own value to the company. This would work to simultaneously benefit the operators and the company's lean operations. Advancing acquired skills only presents opportunities for both companies and employees. While the initial resistance is expected, long-term reaction would depend on proper communication and support. Implementing the right leadership and investing in training may shift the operator's viewpoint from fearful to hopeful.
What would you do to ensure the machine operator were kept busy? Cross-training is a great way to implement into the firm's operation to maintain the machine operator's continuous workload. Cross-training in supply chain management is the training of employee skills and knowledge of beyond their initial work, which is believed to enhance employees' motivation and eliminate mistakes by doing the same task continuously. Moreover, with cross-training, employees are more susceptible to responding to unexpected demand of competition for tasks within the firm. Job rotation is another way to maintain a sustainable workload for machine operators that is similar to cross-training. In contrast, job rotation focuses on providing employees the ability to work in a different part of the supply chain. The job rotation often sets the duration, for example, 3 months or 6 months, whereas cross-training is task-specific. Both strategy contribute flexibility and resilience to supply chain management. Those two strategies should help to ensure the machine operators are kept busy. That's all for the presentation, and thank you for listening.